Looking at this diagram, we see the baseline rules of simple probability. Whether you're flipping a coin for a 1 in 2 chance of getting heads, or rolling a die for a 1 in 6 chance of landing on a 3, the total number of possible outcomes remains fixed. But those calculations rely on a static environment. We need to figure out what happens to the math when the rules of a scenario change halfway through an event. To build our intuition, let's look at this setup. A bag containing exactly 10 balls. They are split evenly, giving us 5 red and 5 blue. Now imagine you reach in and draw a single red ball. Instead of tossing it back, you keep it out of the bag. If you reach in for a second draw, you are no longer operating in the same environment. There are only 4 red balls left, alongside the original 5 blue, leaving us with 9 balls in total. The conditions for your second draw depend entirely on the first. This is the exact spot where calculations often go wrong. Because the physical environment shifted, you have to reduce the total pool of possible outcomes. Your denominator drops from 10 to 9. We call this conditional probability. It is the specific mathematical framework we use to update our chances based on prior knowledge of an event that has already occurred. Let's transition from physical objects to abstract theory. Here we have a standard Venn diagram showing 2 distinct potential events, Event A and Event B. The shaded overlapping region right in the middle represents the specific cases where both Event A and Event B happen simultaneously. Now apply a given condition. Suppose you know for an absolute fact that Event B has already happened. The moment you lock in that knowledge, all other possibilities in the universe cease to matter. Everything outside of the Event B circle vanishes. To find the chance of Event A happening now, you simply look at what's left. You take the overlapping area where A still exists, divided by everything remaining inside the boundary of Event B. This visual logic translates directly into the formal equation for conditional probability. The probability of A given B equals the probability of A and B happening together, divided by the probability of just B. Let's test this with some raw data on screen. Imagine a school with 100 students total. 50 play football, and out of those 50, a subset of 30 play both football and basketball. If you pick a student at random and you already know they play football, what are the odds they also play basketball? By trusting our intuition, we know we can ignore the entire student body and focus solely on those 50 football players. Out of those 50, 30 play both sports. That gives us 30 out of 50, or 60%. Now it's your turn to connect that intuition to the theory. Pause the video here and try mapping the raw data from that word problem directly into our empty formula template. Welcome back. Let's see how you did. Mapping the variables, the probability of a student playing both sports is 30 out of 100. The probability of a student playing football is 50 out of 100. When we plug these individual probabilities into our conditional structure, it builds a complex fraction, 30 over 100 entirely divided by 50 over 100. Since both parts share the total student population of 100 as a base, we can simplify algebraically. That denominator of 100 mathematically cancels itself out on the top and the bottom, leaving us with exactly 30 over 50. That simplifies directly down to 60%. The strict mathematical formula confirms the exact same result we found using intuitive logic earlier. To ensure you execute this properly on an exam, keep these 3 rules in mind. First, look at this list. Rule 1 is to always update your total based on the knowledge you already have. Rule 2, treat that given event as an entirely new universe of possibilities. If the problem states a condition has been met, everything outside of that condition drops away. And Rule 3, memorize the official formula to map your variables securely. Conditional probability is regular probability executed with updated, real-time information. Keep track of your denominator, and the logic will guide you to the right answer every time.